I'm Dirk Cleenwerck. I'm from Belgium. I work for Visma Bosoft. And we, as a company, make construction software, administration that does calculations so that the people that work in construction, when they make an offer to a client, they can make an estimation of the costs and put in a good offer, not too expensive, not too cheap. I'll ask that if you have questions to save them for the end. And the problem, which was surfacing relatively quickly, is that you basically usually have your program talking to the database, straight to the database. And when we got bought by the Visma group, they have a security team. That was one of the first remarks. You have what? You have a Postgres instance open to the internet? Are you insane? So yeah, it's leaving your data open to the internet nowadays is not a good idea. There's advantages to doing things over an API, which isn't only about basically saying, okay, this port is not available to the internet, but when you do it through an API, you have authentication. Before you have access, you don't only have authentication, but you also have certain write settings that you can do on that account. So for instance, this person only has read-only access, that person has read-write. For these tables, access to this person, he's from the accounting, so he doesn't have right to the database for the engineers. So you can limit access to the people that actually need it, which if you have access to the database, yes, you can sort of do that, but it's all a bit more complicated. Also, over the API, usually you work with tokens nowadays, so it's not a straight login. And if you say, okay, this person, their phone got stolen, we're going to revoke access, no problem, revoke the token, and it's done. So all very easy. If you go over the API, it's also a fact that you're not coupled straight to the database driver. So it's not, I'm working with MySQL, I'm working with Postgres, I'm working with SQLite. No, that is irrelevant. You're talking to the API and you get an answer that you then work with. So if you work with the database drivers and you want to switch databases, you have to switch how you work, but you'll see that I can switch without a problem. Also, as we had to do, direct database connection is blocked in a lot of environments, and definitely over the internet, it's not wise to leave that connection open. But normally, if you work with APIs, which I can show here, basically, this is our live API, and you basically send a request, and there's your answer. But what did we request? We requested API v1, and we asked the endpoint addresses, and that's what we get. But that's a predefined statement in the background, so you don't have the same flexibility you do have with SQL statements. So we wanted something that would allow us to use SQL statements over the API. So we made our own classes. So we have a use database. In the project, it's a demo project that's on GitHub. So the link will be at the end on the last slide. But I put it on under an MIT license, so that's pretty easy to use. There's no limitations, so have fun, play with it. It's proof of concept. I on purpose left it like that, so that it's not my way of thinking that works, but you can just play around and see where you go with it. Use database based on the Xojo API 1 service. Why that one? Because some people have legacy code. As I said, since it's open source, if you want to change it from record set to row set, feel free, go ahead. I've also talked to a lot of people over here at the conference. Sometimes we find it difficult to move from one set to the next, because sometimes things are 1 based, sometimes things are 0 based. If you make your own classes, you can just shield yourself from that. You know what you expect from that class. And if you have another source that has slightly different settings, just make sure in your class it still acts the same. So it's relatively easy to work that way. And so we use database, and we do use record set instead of database and record set. So the SQL travels over HTTP or HTTPS, of course, if it's online. But over here, locally, it will be HTTP. And the result arrives as a JSON set. We have a demo mode in the host project. You'll see that that's sitting there. So I'm going to run everything in demo mode, which basically means the database is going to be local. So I don't have the risk of the internet not working over here, which at a conference does tend to happen sometimes. And I can set demo mode to false, and then I'm talking to our production database. I'll probably not go there today. So I'll start up my demo server. Where is it? Okay. And I gave myself the choice of what to work with. I'll start with the SQLite in-memory database. I pressed start, and it populated that database with some data. And now I can request things. Okay, first I'm going to ask for a token. So I'm using a demo refresh token, just an example. And I got back a simple demo token that's valid for forever. And now, because I have a token, I can do a request. And as you see, now I asked for the rows. And we have a second option where we can actually ask for the return info equals true, and that means we get information, as you can see on the fields. First we have a description of the fields, and then we have the record count and all the rows of data. So you see that when I do the return info false, I don't have that. When I have true, I get the field info, and I can work with that. All right, so this is what we get, and as you can see, what we get from the API is JSON. So our other project is where all the work happens. So I'm not going to go over all the code because it's posted online. You can download it and look at it in peace. But you see all the classes. So use database, use prepared statement, use database record, use record set. So it's all there. And we'll demonstrate things as we go. So in your code, you use a database which implements an interface called iDatabase, which means it's easy to add other targets if you want. So if you wanted to add MySQL, for instance, you can use the same interface, no problem. We have two different types of modes. There's one that just works straight on the JSON as we got it. And there's another one that transforms the JSON into an SQLite in-memory database, so that we actually do have all the field info available. You'll see that as well. We have SQL execute for insert, update, and delete. We have prepare for a use prepared statement. We can insert a record with insert record. And the handling itself happens within the module mod SQL, which handles the HTTP transport and the token management. We have two endpoints. So the one is access token, where we requested an access token. And the other one is query, where we basically send the SQL that we want an answer to. As you saw, we get a response that has a row count. So it tells you how many records there are. There's potentially a fields object within the JSON if we ask for the return of the field info. And then you have your rows with all the actual data. And the token is cached per use database instance. If it expires, which in the demo it never expires, but if it would expire, there is code that will get a new access token based on the refresh token that you're using. Because access tokens will expire. For instance, on our production, they last about an hour. And then after that, you need to request a new one. All right, so use database connect. So what connect will do is it'll fetch a new access token to get started, because as it said on the previous slide, it's per database instance. And it'll return true on success or false on error. And close will clear the cached token as well. Now, if I run the second project, closing down a couple of things. All right. I'll just execute this for starters so you can see what it does. So I basically asked the database to give me all the fields from the tracks table and sort them by ID. So you can see that I got the answer right there. That worked with the JSON data set. If I basically click execute DB, it did the same, but now it's in memory as an in-memory SQLite database. All right. So on the slide it said database connect. So up. Yeah. And over here you can see that my token is there. You can see that it's valid till the year 2100. So yeah, I don't think we're going to wait that long. But we do have a connection with a valid token, so we can talk to the other side, no problem. Okay, back to the slides. So we have two ways of talking to the database, and that's just using SQL select, and that'll work in the JSON mode. And I see that there's of course still one slight error on the slide, because originally it had forward only, but that's no longer the case in the current demo code. You can go forward and backward, no problem, in the two modes. And then the second one is the SQLite mode, which basically loads it in memory as a SQLite database. And then we have SQL execute, and if you want to know if it was a success, you basically check db.error, just like you always would, to see if there was anything that went wrong. And we have the use record set, where we can just do a select and get everything within a record set that works just like any other simple Xojo record set would work. There is no difference in how that works. I'll show on the GitHub site, I always also put a comparison page where you can see what all was implemented and what hasn't been implemented yet, and the reasons why. It's all right there. All right, so let's go for a bit more of a demo. So we have a use record set sitting right there. If you look inside of the record set, you can see that behind the scenes, yes, it is running with JSON, but you're shielded from that because you're using use record set. So it acts just like you would use a normal record set, but in the background, that's what it's using. And why is it JSON? Well, you can see that I had the SQL select instead of the SQL select DB. So I'll just press stop for a second. Press stop over here. And I'll switch this one on. So I have a local instance of Postgres server version 18 running now. And I'll switch it here. So I'm going to switch to the background and start the server again. Clear. Okay. So DB, again, we have a token. There's no error, as you can see, so we can continue. All right. And now, because we're running, I couldn't really use an external program to query the database straight off because it was in memory, as you heard me say. So I switched to the SQL one so that you can see what we're doing. Yep. Oh, okay. Yep. So it populated it with the same thing. So we have several tracks going. So one is desktop. So one desktop. It'll do move next. So continue. All right, 2 is web. So 2 web and so on and so forth. I'm not going to let it go through the whole thing because that would take too long. But you can see that it's doing exactly the same thing as you would expect from a record set. All right. So that was the move next. But now we have it the other way around. So we went to the last record. Last record. If we look at the database, last record should be best practices. And we indeed have best practices. If we go previous, okay, so we have API and integration. You can see indeed it's working like a normal record set, exactly like what you would expect. Okay. Yeah. And then over here we have insert. So I'll continue. So the SQL execute, but we have a separate insert, as you already saw. You're going to see that later. So insert into tracks values. The ID will be 7, and it's called adding tests. So up. Now, as you can see, it got added, so that works as well. And then, of course, you need to be able to call it. So adding tests comes back when I say where ID equals 7. As you can see, it's just simple, regular SQL statements like you would normally use. Nothing special. Then we're going to delete it again. So, okay, so as you can see, record with ID 7 is gone. Okay. We didn't get a break here at this piece of code because we asked where ID equals 7. Of course, that record was gone, so we never got it within that if part, so it didn't break, which is what is expected. Okay. Then writing an error handling. So we have an insert record, which does exactly what you expect. It builds an insert from a named column record. It calls SQL execute internally, but in that case you don't need to worry about it because that's not what you're calling. We can also prepare, so use prepared statement, which supports the question mark or the $n numbered parameters style markers. As per usual, if there's an error, your db.error will give true, and the error will be found in the db.error message string, which is humanly readable. Okay. So we're going to do the same thing again. We're going to say we're going to add one with ID 7, and as name it's going to be adding tests. So we do db insert record. So I expect that that's going to be in the database. Okay. So that was the other way to add your record. Just db insert record, and there it is again, adding tests. Then the prepared statement, so where ID equals question mark, and just as you would do in a regular Xojo API 1 version, you set the bind type. So we're going to have an integer, and we're going to bind it. Parameter 0 is going to be 7. So select star from tracks where ID equals 7 is what we should get. So I expect that we're going to see adding tests in the result. And indeed, we see adding tests is right there, so that worked as well. No problem there. Okay, so then we do an error check. All right. Error false. Okay. We again do, that's the next slide. Which is navigation. All the stuff that you normally would expect. Move first, move last, move previous, move next. And as per usual, you test if you're at the boundaries by using end of file or beginning of file, which I don't think anyone's surprised to see that because that's how it always works. So you don't want any unexpected things when you're trying to adjust your code from using a record set to using something like this, because I've already heard that it's a bit of a pain when all of a sudden things are not 0-based, they're all of a sudden 1-based or the other way around. So you don't want any nasty surprises, so you want to be able to change your code without any side effects. I'll also show how I try to make sure that that is the case under all circumstances. All right, so we're just jumping through the record sets now. So we're going to move to the last one. So let's see what the current data is. So the last one is best practices. So we should see if we do move last and we call the ID field, in this case should be 6. All right, and ID is indeed 6. Then we're going to go move first, and we again ask for the ID field, that should be 1. And indeed it is 1. We do a move previous. And are we at the beginning of the file? Yes, that's true. So we were on the first record and we went to the previous record. There is nothing there, so we're at the beginning. And then we do move next. We did move next, so we should be on the first record again. That's what we expect. And yes, our ID is 1 again. So okay. Then reading field values. So we have we can ask for the thing by name. So we have a field with its name and then the value. In case of name, it'll be a string. In case of the price, it'll be a double value. Quantity can be an integer depending on what data you're dealing with. You can have a Boolean value, a date value, or that can be nil, because yeah, a date can be nil if there's nothing defined. A currency value, but not only by name, but also by number. And as you can see, it's 1-based. So that's in the slide. The slides are also on the GitHub. Is there anyone that would appreciate it if I also put, because at the moment they're in Keynote, I can make maybe a PDF. Everybody would prefer a PDF, or do they prefer a PowerPoint?
I have it already for the collection.
Okay, good. Christian already has it, so yep. So you can always access it by name or by index, and it doesn't matter whether you're in JSON mode or in SQL mode, it'll just do it. Demonstrate that as well. So we're gonna again select all the tracks ordered by ID. Okay. So we have a record count. So our record set has a record count, and our record count is over here at the record count here 6. So indeed we have 6 records, so that's correct. Field count, there's 2 fields. Field count 2. Field name 1, the first field is called ID. So we say field name of column 1. So field name 1 is indeed ID. So everything that you would expect yet again. And then we'll go to the next part. which is what you saw on the slide right there. So name, you can ask for the name of the field, whether it's by name that you called it, which is sort of not what I expect you to do, but it works. Or you go by index and then ask for the name. So I'll try to make that a little bit bigger. So field name of the field name is name, which is logical. Field name by column number. So field 2, field 1 was ID, field 2 is name, so that's name again. Then the value of the field name, we're on the first record. So Xojo desktop single platform for the str value, that's over here at the bottom. So yes, that's correct. The ID should be 1. Integer value is 1. Maybe I should, just a second. I'll switch over here, products. Nope. So our price is 99 for that product. So the price, I asked for the double value 99, so that's correct. You can ask for the native value, which you could do with API 1 as well. So ID field native value, here 1, no problem. The get string should be the same, GSval Xojo desktop single platform. And is our ID nil? Yes or no? It shouldn't be nil because that is a value. So is nil is indeed false. So that also all worked as expected. Then of course, it's nice to have data, it's nice to be able to insert data, but of course you need to be able to edit it, update it, delete it we've already seen, but you also need to be able to change the values. So you have edit, so you can edit copies the row into a buffer, so there's no server-side lock. You can say, okay, this field, its new value equals whatever type it is. So in this case, it'll be a string, but it can be an ID as well, of course. Then you have update, which will send it to the database, and delete does what you would expect it to do, that removes the data from the database. Okay, so let's see what's in the database at the moment. We're on tracks, so I'll switch it back to tracks. All right, so we have 1, 2, 3, 4, 5, 6, and then 8, and 8 is demo track, which is indeed what we expected after this instruction, that would be there. All right, now okay, so I called up the record where ID equals 8, so I'm supposed to be on this last record over here. And I'm saying, okay, edit that record, and the field that has the name, its new value will be updated demo track. So I'll now run the use record set update instruction. All right, so as you can see, updated demo track, that also did exactly what we expected it to do. All right, then when we call that record up again, okay. We called up that record and we did delete record. So now if we look, that record is indeed gone. So worked the way we expected yet again. All right, then you have bidirectional navigation. Like I said, that has been updated. Originally, it was when you were in the JSON form, you only had forward navigation, but there was no real reason for that. So I basically checked if I could make it happen to have bidirectional as well. And yes, that made it into the code, but unfortunately not into the slide. So we've already pretty much seen that. So you have navigate backwards is you start at last record, you go move last, and then you can move previous and it does what you expect. And how does this work? It's because you basically, with the JSON, you received all the JSON that was the answer to the thing you asked from the API, and it's all in memory. So whether it's the JSON that's in memory or the SQLite that's in memory, everything's in memory. So you have the whole data set available, and therefore you can navigate backwards, forwards as you want. Now, if you have a question about that, which would be logical, is you can say, yeah, but if I have 1 million records, is that all in memory? Well, that's not how we use our database, because you're going to have long waiting times if you do something like that over the internet, and I would not advise it. We set a limit of 20,000 records, and then if we want to have a new record, we say where ID equals bigger than and the ID of the last record, and there we go for the next set. Well, you split it up in parts so that basically the speed for the end customer is still acceptable, because if you need to wait for 1 million records to arrive over the internet, I think you all know what's going to happen. It's going to take a long time and it's not going to be customer friendly. So just a little side explanation, because yes, it's in memory, and that would be a logical question about, do you handle 1 million records in memory? Well, no, we don't. We buffer it. So then you also, of course, you have the navigate forward, move to the first record, and then move next and loop through it that way, but we've already seen that as well. And then the next interesting step, and that's where you have a difference in between the JSON mode and the SQLite mode, is that when you are in the SQLite mode, you can actually ask what the column type is, and you're going to get the correct answer. Whilst if you're in JSON mode, then JSON, everything's a string, of course. So it's slightly better to work with the SQLite when it comes to that. But of course, because you've received JSON, it takes a little bit more time for the database to fill itself in memory, as compared to working straight with the JSON data that's already there. So you're trading a very small speed hit for more accurate data. That's what you're trading right there.
One question, how do you handle the SQLite in-memory database? With each query, there is a new SQLite database and the old database is destroyed?
Yeah, well, At this point, yes. Because you're on the client side, so if you do a new call to the API, you have a new data set that you got. So yes, that the previous one does get destroyed. You no longer need it. So, but if of course you want to buffer that, like I said, that's why it's a proof of concept project. Play around with it, and you can say, okay, I want multiple different ones in memory. There's no technical limitation to doing that, but it just wasn't within the scope of that project. Yes.
Yeah, when dealing with Postgres database and you say to record set edit and update, you are aware of that you start a transaction when using edit.
Yes, but I was going to get to that later.
Okay.
But no problem. I'll handle it now. That's a limitation of working over an API, because when you're working straight on the database in Postgres, you can say, okay, I'm going to start a transaction, I'm going to do several queries, and at the end of it, I'm going to say, okay, end transaction, and everything's committed. Yep. But it's a REST API, which basically means the one instruction doesn't know about the next instruction. So everything's separate instructions. So unfortunately, that's a limitation. You cannot really have full transactions within that system. The only thing you would be able to do, and that's also what we do, is you fake a transaction in Postgres by not saying begin transaction and end transaction, but by making a block of SQL statements. Yep. And you send the whole block as one go. Yep. And that way, Postgres will handle it as a transaction. But that's the only thing you can do, because you can't do real transactions over a REST API. It just is not possible. So yes, good question. Yes.
Christian has a function called build rowset MBS that creates a rowset without having to create a database. Yeah. So your JSON coming back could be turned into a rowset, return it. It doesn't matter if there's no closing of a database.
Yes, and also a good question. I was going to mention that. That's not in my slides, but I was going to mention that Christian has tools that enable you to do that. Again, not part of the proof of concept project, but yes, you will find code within the project that takes the JSON, that makes it into a record set. And yes, Christian's plugins have stuff that handle that, and probably faster than the pure Xojo code that's in here. But feel free, play with it. It's, that's what it's there for. It's not a final product. It's just something that you can use as a basis to get started and see where you go with it. Another thing is you've seen the refresh token and a simple access token. Well, for us, that's OAuth 2 that we're using, which basically means the customer logs in with their username and password and two-factor authentication, and then they receive an actual token, which can be revoked at any point in time, and that token they can keep using to ask for new access tokens. That system is not within the demo code. It's just a simple framework, but yeah, feel free to add that as well. It's just something relatively simple, because if I put everything in there that we have in production, I think everybody's going to go, whoa, this is complicated. And that was not my intention. My intention was to give a project that actually shows you how you can use it as a starting point. And so we'll see what everybody does with it. I hope I see lots of forks. Okay, so back to the demo. So it's always better to see it actually on the screen as it's working, because on the slides it's all very nice, but if you don't see it happening, then it's probably not real. All right, so we have the navigate backwards and forwards, but I'll skip that part because we've already done that. Okay. So this is the JSON mode, and we're going to ask which column type column 1 is. So column 1, as you probably remember, we're in the tracks database table. So column 1 is the ID. So that's an integer field. So let's see what happens. Okay, so column type JSON, and we get 5, which if you look in the Xojo documentation, 5 means that it's a string. And I did tell you that within the JSON system, everything is just strings. So it is what I expect, but it's not what you would expect if you look at the database, which is why that originally we only had the JSON elements, and I added the SQLite to get around that and actually get that this is indeed not a string, but an integer field. So right after that, we use the select DB, so that'll be the SQLite in memory. I'll put a breakpoint over there. Okay, so column type for the same column, and you can see that it's now indeed not 5, it's not a string anymore, but it is a 4. And if you look in the Xojo documentation, and yes, I kept it compatible with that, because otherwise it would again not be compatible with your existing code. It was supposed to be as compatible as possible with existing code. So you get a 4 for integer. Okay, use prepared statement. That's used to prevent SQL injection. And just like you all can expect, you have the question mark markers, and those are sequentially used. And then you have the dollar and a number markers, which basically you say this is parameter 1, this is parameter 3, this, and so on and so forth. So again, it's on the slides, but I'll demo it real quick. So select star from tracks where ID equals, and in this case it'll be number 3. So let's see what we get. Okay, so I have mobile and iOS for number 3, and that is correct. So then use prepare statement, database prepare. Here I have 2 parameters, number 1 and number 2. So everything greater than or equal 2 and less than or equal is 4. Let's see what it does. All right, so we should be on 2. So we have name is web, and the ID is 2. Okay, that's correct. Move next. Mobile and iOS. And database and data. That is also correct. And then we should be done. And indeed, as you can see, we reached our end of file, so we're out of there. And then, of course, you can use it for the execute as well, not just for the select. So if we look, are we in tracks where ID? Yeah. Okay. So we're basically saying insert into tracks value equals that. So tracks. Okay, here's the prep demo, ID 9. You can see that's what we did. update tracks set name $1, where ID equals $2. So our first parameter is updated via prepared statement, and the ID will be 9. So I fully expect that record to have been changed. So as you can see, indeed, it has been correctly changed. And okay, we're approaching the end of the demo. As I already mentioned, there's an iDatabase interface. So at this point in time, the code as it has been delivered supports SQLite and Postgres, but you can add whatever. As long as you follow this interface, everything should just work. So shouldn't be a problem. If you want to add something through ODBC, just make sure you follow the interface. You want to add MySQL, follow the interface, and there should not be any problems whatsoever. So you can swap out, use database for a test double, no problem at all. And the same code will compile with any future backend. If you look at the code for that, so you can see that here I'm not saying that this is a new use database, but I'm saying it's a new iDatabase equals new use database. And if I put my breakpoint here, okay. So we're back on the record 1, so desktop and ID 1. But as you can see, we did not say new use database. We used the interface directly this time. Okay. All right, so the Xojo demo server is the one project, so that was the one that acted as backend. That's the one where you're going to see that the backend could have been a SQLite, or the backend could be Postgres, or the backend could be whatever you want it to be. It has an endpoint to ask for a new access token, and it has an endpoint to send your queries. And you have two different modes at the moment, mode SQLite and mode PostgreSQL. And if you want to add one, you can do that. What we built, there's a use database, there's a use record set, they're API 1 compatible. It's over HTTP, or if you put it on the internet, please don't do HTTP. Make sure you do HTTPS to keep it secure. There's JSON mode and SQL mode. The advantage of SQL mode, as you've seen, is that you have the column types, which you don't have with the JSON mode. You have prepared statements with question mark and dollar parameters. There's an iDatabase interface for testability and dependency injection. The Xojo demo server is made so that you can locally test and see if everything works correctly. What are the remaining gaps? You have a commit and rollback is not possible over stateless HTTP, as I mentioned earlier when the question was asked. And theoretically, you could make the code asynchronous. You saw that when I was in debug mode, everything took a little bit of time. That's because it's synchronous instead of asynchronous. And yes, you can do that, but was not part of the demo project. You can find the repo online, and now I'll basically show something from the repo. So that's over here. And I put this in there. And that gives you an idea of how much of API 1 has been implemented in the system or not. So it nicely explains it. It says which methods are available, use database, and then side by side, the Xojo database element versus the use database. So you can see what was not implemented. So we already said that. There's no commit, there's no rollback, because you can't do that over a REST API. But like I said, if you work with Postgres as a backend and you want to sort of have something similar to a transaction, send all your code in one block. It'll consider, if there's even one of those instructions that fails, Postgres will reject the whole thing. So it sort of works a bit like you would have a transaction. Okay, so table schema, field schema, index schema, and database name, host, username, password, not implemented. The database record class, okay, you can again see it's mostly implemented.
On Postgres, you can use a normal select to get field names, table names in the center.
Yes, but of course that's if you use the Postgres backend, and since we can switch backends, you're not guaranteed what you have.
That's information for people using
Yes,
Postgres.
yes, that's correct. So, and we use Postgres at work, so really happy with it. We've been using it for over 20 years, so I can only recommend it. And then the record set, but you can see how many things are checked, so there's almost a complete implementation. All right, and last thing to show. Okay, I'll clear the log. And I'll basically say run tests. And that's what I meant when I said I wanted to make sure that everything stayed working. It basically ran 151 tests to see if what we expected is actually what we got. It made, under my documents, I use record set test report. So let's go see. Okay. So there we have it. It has all these different things that it tests to make 100% sure that our code works. And a last kicker, so that's 2 projects. And I already told several people I wrote 0 lines of code. I told Claude Code, okay, here you have some code from our project at work. You can use that as a starting point. Okay, here's some documentation from Xojo API 1. Please implement our use record set and try to keep it compatible with what's in Xojo API 1. Then I basically, as I was progressing, of course it made mistakes, you correct the mistakes, and I asked it, okay, so how far are we down the line of compatibility? The document you just saw where everything has green checks, that originally, of course, was absolutely nowhere near complete. And I kept on saying, okay, so we still need to do this. Okay, we're going to handle this one step at a time. So please add this. Okay. Write tests for this. The tests are very important. Make sure you test everything. All right. So, and as you can see, yes, the documentation is there as well. So I had Claude Code writing that documentation as well. There's manual.md files in there in the project. You're going to see that explains how to use everything. That was done by Claude Code And basically, I went one step at a time till I went, okay, I think that's more than enough for the demo. So there's 2 projects, and I wrote 0 lines of code. And yes, that's with Xojo projects. So it just gives you an idea. If we had tried that 1 year ago, forget it, that wouldn't have worked. But now we're this far. And yes, that means our job did change somewhat. We're still programmers, we're still in control, but we use the AI to help us be more productive. Because this, if I had to do this whole project myself, that would have been quite a big amount of work. And this was done in a couple of days because I managed to use it through the AI. And I tell all my colleagues, don't be scared. It just can help you in your productivity. So use it as a tool and you should be fine. All right, that's what I had for today. I don't know if there's any questions. Yes.
Two things. First, great job and nice presentation, thank you. And second one is when you insert the new record and the ID is generated by the database, would it be possible to get the ID generated by the database to the answer?
That's also at this point in time not something that I handled within the code. But yes, because you are of course working on a state as you have it in memory, theoretically it can have changed on the back end. I did not implement anything to take care of that. It would be difficult with, for instance, the SQLite database because you have nothing that will warn you that the data has changed. With Postgres, you can use triggers to give you a warning that the data has changed, and then you can refresh your data before you actually do anything. So that you wouldn't have any conflicts, or at least throw up an error in case there's something already on the back end. In this case, because there's nothing implemented, let's just say that Mark Seeler over there at the back, he inserted something into the database and it had a record with ID 8. And then you do the same. What you're going to get is database error. That's why it says in the code that basically you need to check your database error because
I don't want to take care of the ID insert, generate the ID by yourself, but give it back to
yeah.
Rejoining ID
Then-
Postgres.
Then you would of course have to set your database structure up to auto-increment those IDs and then you can skip that whole thing. I did not have that over here, but sometimes there's limitations to a demo project. But yeah, within our production environment, we don't insert IDs ever.
I think he
And,
wants to get the result from SQL insert ID.
Sorry, what?
I think he wants to get the result from SQL last insert ID. Yes.
Yeah,
So not after increment, so the issue is to get the ID of the inserted record.
Exactly.
yeah, but you could do that as well. It's just API on the other end. So you can ask the API to send you the ID back as a result, but that's not implemented. So, but yeah, you would be able to do that. I don't see any technical reason why you wouldn't be able to do that. And you will have a conflict if two have the same, but then you're going to have database errors. So.
In Postgres, you can just use the insert statement as a select statement. Say insert into table, blah, 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 returning
Returning
row
ID.
ID.
Yep, works fine. Yep. Yes.
So how do the prepare statement safeguard you from the injected?
That I basically didn't check into that exactly. I mostly implemented everything to keep it compatible. To be quite honest, I don't know when you transition it to an API call, how much that will influence the whole thing. I did not check that. So I can check that later and get back to you if you want me to do that. But I did not check that.
It's a sensitive topic, and I kind of thought about this.
Yeah.
The backend I'm using is there is a list of things which are allowed, and I'm using them. And then if I would be writing the backend, essentially, how to handle that, it's it's not something where you can write a list of these are bad things, because they'll come up with new things which you didn't think of.
At work, we don't even use prepared statements. We basically have everything for us is SQL, everything. We have a framework that builds the SQL strings automatically. So we, because of that, never ever use prepared statements, but to be compatible, it had to be in there. So,
Yes,
but I don't know.
I mean, to be compatible is when you make both ends and
Yeah.
you're using them. For the bad actors who somehow pass through your authentication and then they just start inserting things which.
Yeah. Yeah. But you theoretically need to validate everything that's user input. And that will make not much of a difference whether you use a prepare statement or not, but yeah.
Okay, thank you.
Anyways, yeah.
That statement will protect you that nobody inserts apostrophes or brackets. At the point where the SQL interpreter would say, oh, these are many commands, and you just wanted to change a word, the string. Yeah? So the prepared statement reassures that you only get a string inside this value, the placeholder,
Okay.
and not a bracket and another command.
Okay, yes.
Just leaving the prepared statements a bit at the side because of there's lots that can be said to this. But you said that you have a problem that in the JSON mode you can't bring over the type information. And I think there shouldn't be anything that would hinder it to implement. Because when you first in JSON, you don't have only string. There are several data types defined for JSON. They are less than, of course, the Postgres database would support, but you always have some type mapping. So either you could transfer directly with using more than string data type on the JSON API, or what you've shown us that you are able to send some metadata with the JSON from the table structure, and there you have the type information. So it should be possible, even within the JSON interface layer you have, to instantiate the variants with the proper type information, so that you can get the type information from the social
And especially if you do this one. But this is so specific for the way that we handle stuff that I didn't implement this. Because over here, if you actually ask for the return info equals true, as you can see, the information is already there.
Yeah, exactly.
So you know exactly what you got, but I did not implement that. So, and within the implementation, within the demo project, that is not, you're going to get a string for everything that's in the JSON format. But could you work around that? Yes. Again, feel free to play with it. There's no technical limitation, it's just not there within the demo project, and I wanted to be upfront about that within that system, you will get a string regardless of which field it is. So, you know, at least you shouldn't be surprised. Okay, any other questions? Yes?
Yes, so you said that all of this was much easier thanks to AI to write all of that. What is your typical workflow to use AI to write Xojo code?
I start with example code. So we already have stuff implemented within our program, so I basically took some of that code and gave it to Claude Code as an example. Then I tend to add everything that I think will be relevant, like from the Xojo documentation or from the database schemas that we have, and I will add that all and point Claude Code at here are the files. I usually just dump it into a folder. There are the files of the documentation that I want you to use as a reference, and this is what I want you to do, and here's already a small example of what I sort of expect. And if you're that specific, it tends to perform really well. It's if you're not specific and you just say, okay, write some code, here's a page of the Xojo documentation, then it's probably not going to handle it all that well. I heard multiple people saying that it tends to get confused in between API 1 and API 2, but because I'm that specific in what I'm expecting, and I give that much documentation to get started with, I think for this project I had about 15 different files in the folder, and I told it to look there and get started. And then of course I still had to correct every now and again. Everybody that's played with AI knows that you need to give it its corrections. But it performed better than I expected.
So that was using Claude.
That was Claude code, yes.
And Claude was directly modifying the Xojo files.
Yes. It's basically, this project, as you will see, is Xojo text, but it also works perfectly fine. I've done it on our production system on Xojo XML files, and it'll handle that just fine as well. It's just binary files that won't work, but that's sort of what's expected, I think.
So I'm actually asking this because the presentation I wanted to do here at this conference was using Claude code to make an app. And I just tried, and always the file just became garbage, and I was never able to actually get a working file.
Well, here you have two of them. I can give you my info files that I gave it, so that you have a bit of an idea of exactly what I gave it. Because I've noticed if you do not give it enough context, it will do what you said. Yeah.
It would be useful for me. I think it would be useful for anyone here if they were happy to share.
The instruction set, the instruction file.
Yeah, instruction sets.
I'll see if there's any business secrets in there. I'll take that first. But yeah, if it's possible, I will add them to the GitHub repository. Okay, no problem. Yes.
I want to talk about not implemented functions for asynchronous requests. So right now we have a code which bufferized the result of the server side.
Can you speak a little bit louder because I'm a bit older and sorry.
So I'm talking about asynchronous requests in the application. So it says that it's bufferized on the server side with the size something about 200,000 records, and it deletes each time when you have a new request, right? So my question is, you give the interface like move last, move next, and so on, but I have no stable result if someone make a new request. So I make a move, will execute a move last, but there is already no resource, buffered resource in the server side, and it will lead to the unexpected behavior. What is your thoughts about how you want to implement this asynchronous queries?
Basically, the part where it is synchronous at the moment is in the API requests that it sends to the API delivering the data. So that's what needs to be improved because it was a little bit slow here. If you do it on Windows, it's even more slow. And in our production system, those are handled asynchronously. And then you're not really waiting on the data, and just the moment the data is there, it gets triggered and your code continues. Since you're dealing with live data, if you're working this way, you probably would need to have a system whereby you can say, okay, I'm changing this data, so I expect a trigger to be sent to anything that's listening to it, because first of all, your data set that you have at this point in time will be a temporary snapshot, not a live presentation, and you theoretically want a live presentation. And on top of it, if someone is sending changes, you want it to be blocking on the other end.
Yes.
So, yeah, so it doesn't do that, but it's definitely possible. But at this point in time, no, it doesn't do that. And yet again, It was easier for us to do that within our production system because it's one target, it's Postgres, and we know how to handle it, we know how to deal with it, we've been working with it for 20 years, we know how to block stuff, we know how to say okay, a trigger when the data gets changed, and we can listen for that on multiple different backends, no problem. But because I was dealing with multiple backends for this demo project, and certain backends won't have that possibility, it'll be up to the people using it to implement a system that makes it safer, because this is just a framework. So yeah, but you do need to make it safer if you want to use that in production, because it could go wrong, yes.
And another question, could you compare the usement of, so normally we have API, and we have resource, which we address some parameters and send. You have a raw SQL in your state, so you have raw state. And for example, if you change the structure of the database, you actually depends on the database structure in your code, and you need to change all the queries in your code. So do you have some issues with such, for example, when you often changing the database structure? Can you handle all these changes in your code also, in each query?
Over here?
Yeah, so your experience about that. So because normally we're working with API, we have only one endpoint,
Yeah.
and you just change it because the structure of the database was changed, and it's okay. But when you have a lot of SQL queries, you need to change it all. So what is your vision about that?
There was nothing in the code here that actually has any set structure. It basically sends the SQL to the other side, and the JSON element you get back contains all the fields, and it's based on that result that it builds everything on the receiving side. So it basically doesn't really know what's on the other end. You could implement that, but then you would have to implement something whereby you say, okay, I'm first going to send something that requests from Postgres how these tables are structured. You could do that easily, no problem. And then on your end, rebuild that in memory or create a local database.
The syntax of this query is in code, so you need to change it else. So it's complicated or not?
I don't really see a problem, but
No,
maybe I'm
it's not
misunderstanding
just,
your question.
It's another approach.
Okay, I would say talk to me in a minute, and I'll see if I can give you a better answer, because I don't think I'm quite understanding exactly what you're asking. So I'll talk to you in a minute, and I think I'm done.
Thank you.